Hi, Visual Investigator is the solution we position in the market for policing, procurement integrity, detecting and investigating fraud, and preventing child abuse. I'll demonstrate now a different type of investigation, the development my team has done in order to show the Visual Investigator capabilities to do contact tracing in the COVID-19 pandemic. We've been working with the Ministry of Health of Argentina in order to understand how the non-pharmaceutical interventions have impacted the disease transmissibility, the R0, in this country. We recently received a commendation letter from the ministry. I am going to show you how Visual Investigator provides public health agencies with the first three core capabilities Sean talked about: a contact tracing database, additional enriching data, and intelligent alerting. But I will also show an initial look at the fourth capability, advanced public health insights, by showing VGQB, Visual Graph Query Builder, a prototype solution extension in Visual Investigator to enhance its capabilities. We configured alerts based on high-risk scenarios aimed at mitigating the propagation risk. The data we're using is fictitious. It would all come from different entities or devices from the public sector, such as tax agencies, LPR, license plate recognition, or social benefit departments. The first alert we see here was triggered because of the following three conditions. Ramona Gutierrez, the alerted person, is associated with a network with confirmed and suspicious COVID-19 cases. She works at a high-risk place, and she also keeps moving around the city during lockdown. Here we can see the corresponding network for this alert. We'll open the alerted entity and explore it. Ramona is a 37-year-old woman, married with 2 children. If we expand Ramona in order to see where she lives and works, we can see she needs to travel a long way to get to her workplace. For the sake of time, we have displayed the different subnetworks of interest. Ramona works in a nursing home, which is a high-risk place and where there's another person alerted. She lives with her husband, Mario Lopez, who works for a company where 2 people have been tested for COVID-19. One of them was confirmed. And Ramona has been moving around the city during lockdown. If we look at the date range, and since the lockdown in Argentina started in March the 20th, we can see here she's still going to work. Up to here is the work my team has done. The big question is, how many Ramonas can we potentially have in our network, representing a high risk for Argentinians? This can be answered using VGQB, which allows us to search for all people meeting the same pattern, working in a high-risk organization, sharing their homes with a person exposed to the virus because one of his or her colleagues is infected. In other words, the Visual Graph Query Builder enables pattern matching within the graph. So we select the subgraph of interest and add the pattern to the Graph Query Builder. Once it is loaded into memory, we run this query and can find other cases. Here we found, for instance, a person who works in a different nursing home and shares his home with a person potentially exposed to the virus in his workplace. We can even restrict parameters of this search on a node or link level. For instance, we can look only for confirmed cases. So we'll need to select the COVID node and modify the corresponding parameter. In this case, if we repeat the search, we'll get fewer results since we are now looking only for confirmed cases. But even more interesting than that is that we can generalize the search and look for different variations of the same use case. What we are looking for is to identify all people working in high-risk institutions somehow exposed to the virus. That we can do within any node. Once the node is added to the query builder, we will restrict it as to find 1 to 5 nodes in the middle and run the search again. So now we have more generalized cases for the pattern we were concerned about, and this pattern can be used to feed the alerting process. The ability to find patterns in networks like this is currently not possible in public health agencies, and it would add a great value to the work they do. SAS unleashes sophisticated technology for average users, policemen, public health officials, and so on. This very same methodology can be used for detecting financial fraud or any other domain where visual investigator can be useful now.